Start recording, okay. Hello, what's up, Professor? My name is Nick. This is going to be my video for the Jedi lesson. So we're going to start with question 5 here. I'm going to explain question 5 for you. Suppose a man's scalp hair grows at a rate of 0.4 millimeters per day. What is this growth rate in feet per century? So when I saw this question, the first thing obviously is dimensional analysis, which I'm pretty familiar with because chemistry took me down that road. Chemistry. So we start with 0.40. I'm going to be using the sketch pad. Millimeters, and then the magic 1, obviously. And then we want to switch the millimeters. This is millimeters per day. Sorry, so this 1 is actually for a day. And I have my notes here that I'm using. We want to switch 0.4 millimeters first, and we want to take that to, I assume feet. Is that what it said? Yeah, feet. So we want to put millimeters on the bottom so that these cancel out, respectively, and we want to put feet on the top. And because feet is the bigger unit, we want to just have that one have the 1. And 1 feet into millimeters is going to be 304.8. So 304.8. Sorry about my handwriting. So these cancel out, but what I like to do is I like to take it in the same thing. Go ahead and cancel day. So to cancel day, we want to put on the opposite side, so we want to put on the top. So I'm pretty sure it's century. Century is going to be way bigger than 1 day, for sure. So we want to put the magic 1 for the century. I don't know if this one's magic, but this one isn't magic since it's converging. Anyways, 1 century into how many days? I switched it to years, but days is faster, so it's 36,525 days. 36,525 days. And this is like the complete dimensional analysis here, where obviously we cancel days in millimeters and we get feet and centuries. So now all we got to do is calculate. When use this little squiggly line. I don't know where my calculator is. I lost it in my room. My room's a mess, so I'm just going to use my phone to use the calculator. But if we do 0.40, you want to multiply the top and then divide by the bottom. Obviously, you don't have to look at the ones because, I mean, like, so 0.40 times 36,525 is 14,610. Then we divide by 304.8. Yeah. So you get 47.93. And obviously you want to round. I like to round to 3. Does it say to round? Doesn't, but you know, I like to round to the 1 after the decimal spot. So 47.93, which is also 47.9. And then you want to use the obviously the units that you got. So it would be feet per century, and that would be the final answer here that I got. If a man's scalp hair grows at 0.40 millimeters per day, what is the growth rate in feet per century? 47.9 feet per century. So that's question 5. That's why I wanted to do. And then I also wanted to look at question 11 because this confused me when you were explaining it a little bit, but I think I got it down now. So if I can just find the eraser here. Oh, that's not good. Okay. Let's just do it at the bottom. I guess. Oh, okay. T equals 2. Let's just write that down at first. So, wait, actually I could just do this. It's taking forever. Boom, 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 boom. And boom. Okay. So T, let's just write this down before we even read. I like to write them down. So T, or it was a capital T. Let's go back and undo that. Maybe pencil's better. T equals, from what I remember, it was 2 pi radical m over k, yeah, m over k. And let's read the question out. A spring is hanging down from the ceiling and an object of a mass m is attached to the free end. The object is pulled down, thereby stretching the spring and then released. The object oscillates up and down, and the time t required for one complete up and down oscillation is given by the equation t equals 2 pi radical m over k, where k is known as a spring constant. What must be the dimension of k for the equation to be dimensionally correct? Well, since we're talking about time here, I assume, yeah, we're going to want to ignore the 2 pi on this side, because we're not really looking for that right now. We want t on that side. So it would be, or no, we want t on both sides. So if we want time on both sides and we're ignoring the 2 pi, we want to keep t, and the new equation would be m over k. And then what you want to do is you want to square both sides so that you get rid of that radical. So it would be m over k equals t squared. Oops, t squared. Okay, and this m is the original unit of conversion over here. This is just, or the m that this is talking about, which stands for the mass. And we want t over here. So the thing that we want to do is, wait, right? Yeah, t 2 squared m over k. Put that t m over t. T equals m over t squared. Yeah. So we want to switch these two and we want to solve for k. So k equals m over t squared. And it's asking us what must be the dimension of k for the equation to be dimensionally correct. So if k equals m over t squared, and m is, let's do this, m is the mass, so m brackets, and then brackets t squared brackets. This would be your final answer when you solve for k to figure out what the dimensions, so that it could be dimensionally correct. This is the answer right here. And check back over here, m over t squared, that is correct. And yeah, that is it's a spring constant. K is a spring constant. But those are my explanations for those two for week 1A, I think. And yeah, that's about it. I'll see you on the next one, Professor.